Did you not do that before?
Pythagorean Theorem. This is 8.2. I think we've been covering this a whole bunch. So we've actually done the Pythagorean Theorem in the past. This will be somewhat of a review. Review's always nice in the middle of a busy time. Just keep it up in your mind. All right. Something I thought was really cool, though. The Pythagorean Theorem is ancient. It is really ancient. The Pythagorean Theorem is one of the most famous theorems in mathematics. The relationship it describes has been known for thousands of years. Okay, there was a man named Pythagoras whose name goes to it, but
I can't even. Oh, wait.
I'm going to make it larger in a minute. Pythagoras' name is put to it, but it's thought that Pythagoras isn't the one who actually discovered it. He's just the one who made it famous. Okay, there's even some thoughts that he went to Egypt to study, and that he got it maybe from the Egyptians, and I'm going to talk a little bit about that in a minute. This is a picture of a big, huge timeline, and I have it on my wall in the back there. If you've ever gone down that hall, you've seen a big timeline.
That's what it is.
And I'm going to enlarge this. Okay, I took a picture of it. I'm going to enlarge it. Okay, so right here is the Pythagorean theorem right there. Okay, so I want to show you what other things were going on in history. And this is about 570 BC, so 570 years before Christ. Was going on. I want you to notice that Nebuchadnezzar was the king of Babylon. Who was in Babylon when Nebuchadnezzar was there? Daniel. And so this is ancient. I'm talking ancient. So that means the Pythagorean theorem was going on. People would have known about the Pythagorean theorem, at least in Greeks and Latin and Romans, when Jesus was born. So if Jesus went to a school where he learned some of the Greek math and stuff, he could have learned the Pythagorean theorem. So we'll have to ask him when we get up there. And so I just think it's really cool. This is and it's even it happened before Alexander the Great came and conquered. This was way back there. Pythagoras knew this stuff. Now the cool thing is what I wanted to show you is it's thought, let me get a blank piece of paper here. It's thought, let's clear all that the pyramids, this really cool thing about the pyramids is I don't know if I can draw it very well. The pyramids are a square on the bottom, and then they are a pyramid that comes down. Can you kind of see what I'm talking about with that?
Yes.
Mm-hmm. All right. Now, the Pythagorean, this right here, if I took that and came across, I'm going to undo some of these lines, and came across there, it's in a 3, 4, 5 ratio. We talked about the Pythagorean triples.
Okay.
So that this would be a right angle. All right. Now, another one.
That's cool.
It's really cool, and let me put these back. So if I came, do that again. I'm going to put a dot there and come down. Oh, you can't see from the top down. That's really hard.
Yeah, that is.
No, that's good.
You can see it? You
I
can see
think
that?
I can see it, yeah.
Okay, so let's.
better than 40.
Okay, so you can see down, right?
Yeah.
And so if I come, let me enlarge this. If I come down and then over, do you see that's going down and over? This is a triangle, and they're starting from the tip of that down and over. If I understand my math right, and when I was looking online, that's also in a 3, 4, 5 ratio, so that it's at a nice, perfect. So I really think that those Egyptians knew the Pythagorean theorem, all right? Or at least they knew that a 3, 4, 5 triangle made a right angle. Whether they knew that 3 squared plus 4 squared equals 5 squared, I don't know, but at least they knew that a 3, 4, 5 was something that made a right angle.
So
Okay?
it's not possible they could just think like me and say, why don't we just make it in like this shape and put these here to just make it go like
They were
that?
very good engineers, I'm telling you. All right. So that's some just history over here about it all. All right, so this is what the Pythagorean theorem actually states. You don't have it anywhere that you have to write it. You can just watch here. In a right triangle, the square of the length of the hypotenuse is equal to the sum of the square of the legs. All right? So we have a hypotenuse. We have some legs. Something really cool, another thing that really works well, this is actually kind of like a proof for it. This is a right triangle here. If this is 3 here, and 3 squared is like the area, and you have, how many boxes are there?
9.
9, because that's 3 on this length, and that makes 9. That makes 3 squared, right? There are, and this is 4, and 4 squared makes an area of and so that's 16, right? This is 4. What is 4 plus 16?
4 plus 16?
I'm sorry, 9 plus 16.
25.
25. That should work, right? Because that's 5 squared. So we have a beautiful thing there. We got the legs. So if I take my legs and I square them, I add them up, it will be the square of the hypotenuse. Okay? I thought this was a cute little, we got not a hypotenuse, we have a hypotenuse. You could draw that on there. It's a little hypotenuse.
Don't ever.
We're going to talk about this adjacent and opposite. I'll probably come and bring this this little picture back when we talk about that sine, cosine, and tangent stuff because you've been memorizing them, but you don't know what they're for. But I thought that was really cute to have it, not a hypotenuse, but a hypotenuse. All right. I have another little joke here. I got this offline too. It's really cute. This is a right triangle, and she's giving birth. This is the birth of a right triangle. Here we go. This is what the doctor's going to tell her. He's too big. We'll need to do an a squared plus b squared section. Which is a what kind of section?
A C section.
A C section. And how'd they get the C from this?
It's the square root of a squared plus
Yeah,
b
they took the
squared.
square root of both sides to get the C squared.
That's
section.
funny.
I love it. Anyway, math joke. Here we go.
That's what I was like. Oh
Now
my
here's another
God.
joke. I thought I'd share this with you. I'm loving these jokes right now. Here we go. What do you call a teapot of boiling water on top of Mount Everest?
I feel like we heard this
So-
just like last.
We did. We talked.
Let me think about it.
A teapot.
I'm just gonna sound really crappy.
It is.
Sound really stupid.
It's up on Mount Everest, so it's up
Hi.
high. So it's come on, a high pot in use. A hypotenuse.
I knew.
I love it. All right. Just so okay. So now that we've talked about all those jokes and the history, let's do some problems with the Pythagorean theorem. The a squared plus b squared equals c squared. I've got them. If you want to mark them, I've already got them written down. We're going to do numbers 1, 2, 5, 9, and 10. You can. We're going to. I've got them there. If you want to circle them there, if you can, but you don't have to. 1, 2, 5.
The numbers you can. Okay, yeah.
6, 9, and 10. I have a way to do that so that we can just get quickly to them.
6.
And I want to take out those. Cancel. Let's go here.
That's all the numbers?
That's
1,
all
2,
the numbers.
5,
1,
6.
5,
1, 2, 5.
1, 2, 5.
9 and 10.
1, 2, 5.
6, 9, and 10.
Yeah.
6, 9, 10.
Yeah, 1, 2, 5, 6, 9, and 10. And so
yeah.
I can do this here, and I think we can see them better. I can bring them up. All right, so remember that the Pythagorean theorem is a squared plus b squared equals c squared. You could put the c squared on either side. Of these numbers over here, which one's a, which one's b, and which one's c?
So that matters.
It does matter.
C is the hypotenuse.
C
the others
is
don't
always
matter.
the hypotenuse, and
others
these
don't
two
matter.
don't matter.
Hypotenuse is the biggest.
Is always the one opposite the 90
the right
angle.
angle. All right.
Okay? Now, so I want you to stop for a quick, and we're going to do this two ways, okay? We're going to put our 4 squared in here. We're going to put our x squared in here. That's our legs.
Oh, those are okay.
And we're going to put in our hypotenuse squared. That's a 5 squared, okay? And when we're all done, you're going to go, oh, man, and I'll tell you why in a minute.
Are we gonna all go oh man in a bad way or oh man in a good way?
I hope it'll be a good way because it'll save you time later. All right, so what's 4 squared
16.
and 5 squared?
25.
$81.
Almost. Yep. So we're gonna get x squared, not 81. No. I'm gonna subtract that. I'm gonna subtract that 16 to the other
You
side.
get 9, and then you have to do the square root to help the
Yes.
two out.
Oh, I see what you
And
did.
x
Square
equals-
X
root,
squared
not
equals
square.
that. Yes, you're gonna square
Yeah,
root.
yeah.
Very good. X
Which is
square
gonna be
root.
3.
Yeah.
X equals 3 now.
I
I'm
got
gonna put this right here. I'm gonna put this equals 3 right there. What kind of a triangle was this? A what?
All right.
3, 4, 5.
A 3, 4, 5 triangle. So
We could have figured it out.
you could have done that. That's why we
Well,
memorized your
that's what I was
Pythagorean.
gonna ask
That's-
before you even did it.
So
but
that's
I
why
just
the
went with it.
oh man. Okay, so let's look at the next one, number 2, and see if it's a Pythagorean triple.
It's not.
9.
Is there anything below that's a Pythagorean triple that you won't have to do them? Remember we learned 3, 4, 5.
And 5, 12, 13.
3? Couldn't it be like 6,
Yeah.
7, 8?
4 is.
Or wait,
4 is.
12.
I heard 4 is a Pythagorean triple, so you might want to do that one fast. And is
Question:
there any?
On these that have measurements, we wouldn't have to do squared because we're not finding the
That's
area,
correct.
correct?
Wait, is that 12? 4 is 12, right?
Yeah, because 5,
Yeah.
5, 12, 13.
I want to look at number 3. I'm going to look at number 3, and
Well-
we're going to do 2. Actually, let's just trade it out. Let's do 3 instead of
Well, hold
5,
on, I'm
2.
almost done with 2.
I know, right?
Yeah.
Same.
All right, let's do 2. Not 2, 3. All right. Number 3 real quick. I'm going to tell you that this is a Pythagorean triple.
What?
Well, it looks like it would be 6, 7, 8, but I don't know if you can
There's
do
no
that.
such thing as
You
6,
can't
7,
do
8.
that.
3,
You
4,
can't do
5.
that.
It's going to be
So
10.
I heard it's a 3, 4, 5.
gonna
Why?
be 10,
This is if I take the 3, 4, 5, if I take the 3, 4, 5
Oh.
and I double it, I'll have 6, 8, 10.
Yeah, I get it.
All right, we're doing number 3. Brett, ready? If I take a 3, 4, 5 and I double it, I
Yeah,
have
I
6,
got
8,
you.
10. If I triple it, I'll have 9, 12, 15. So any of those is also a Pythagorean triple. So
So 2 is 15.
so number 2, not 2, no, because it's,
What?
oh, yes it is. Number 2 is a Pythagorean triple also, and it's 15, yes. So if you know your Pythagorean triples, it'll
Huh?
save you time. Look at this.
Okay,
How is that a Pythagorean?
12 can be
Because it's a triple of this
4,
one.
9 can be 3, so it's going to be 3.
And 8 are ugly.
I am going to
That's nasty.
reiterate that this 3, 4, 5 is powerful. Powerful. And the 5, 12, 13, if you know it's a multiple, if you notice, hey, look, I have a 6 and an 8. Oh, 6 and 8 are doubles of 3 and 4, so I would just double the 10 and I'm done. You don't have to do all the Pythagorean theorem for it. That's why I had you memorize the 3, 4, 5 and the 5, 12, 13.
Okay, wait, I'm going to
Let's go to the next one. It was going to be
wait, I'll write this down. It would be
5. Okay.
9, 12. Okay.
Okay.
What's the radical
Let's go to
formula?
5.
What is that?
All right. 5.
Square root.
Is this a Pythagorean triple?
Oh.
Is this one a Pythagorean triple? 11 and 14 and something.
No.
All right, so let's do it together. What's c squared?
Oh, yeah.
11. Oh, wait, 14.
Yes.
Because it's for this one.
And a squared plus b squared, does it matter which one I put for
No.
a and b?
No.
It does not. So I'm going to do, I don't know, I'm going to do 11 squared plus x squared.
That's exactly what I did.
Amy, did you ever tell me what 14 squared is?
196.
Yes. And
Oh.
11 squared?
121.
121. I need to subtract that
I got
121
5
over
square
there.
root 3.
That's what I got too.
X squared equals, just a second, let's don't go too fast. Let's go 5,
Sorry.
7, 75. Is that, I got,
I got 75, but then you have to square.
yes, then we have to take the square root of both sides. We're going to have to take some doubles out. I know that 75 is 25 and 3. You could do the 5 and 5.
I know we weren't planning on doing 7 and 8 together, but
Yeah,
can we
can
at
we do
least
one of
can we
them?
do one of them because they're really ugly looking.
Probably.
On 6, I got 2
Oh, I'll
square
trade
root
it for
2.
6
Me
then.
too.
I'll trade it for 6. Let's do 7. 7 instead of 6. Okay? Amy, what did you get for number
We
5?
already- we already did 6.
What did you
I
get for number?
got 5 square root 3.
That's exactly what I got. All right, let's trade it out. We'll do, instead of doing 6,
Wait, this isn't
let's do
this,
7.
This isn't too bad. All we gotta do right is just because the thing that makes it bad is the square root. All we gotta do.
We're squaring it so we get rid of the square root.
Yeah.
No, all we gotta do is just square the 82 and then multiply by.
Yeah, I'll show
2,
you.
Right?
Let's do it. Let's do 7.
Alright.
If we
Multiply by
square
7.
if we square the square root of 82, then it just becomes 82.
Yeah,
Yes.
Exactly.
Yeah.
Sweet.
So then, but no, well, let's just say, let's do what about 8 though? Let me see some.
64.
8's got, oh no, same thing. All right, so then if I go I go
We square
c
a square
squared,
root, they cancel.
c squared, which
Yeah,
one's
each times
c
square root,
on number 7? Which
means
one's
it's
c?
gonna be 64, right?
Yes.
Wait, what?
Then c is the x squared equals, right?
No,
And then the
okay,
a and b
right.
is 8 squared plus square root 82 squared. And that 82 squared root
Yeah.
becomes what?
All I heard
82.
was square
Just plain
root.
old 82. That's right. They kind of zap each
I'm
other,
sorry.
right?
Um,
There's that fire you guys were talking about with the
so what?
and 64 and x squared. I
Oh,
get,
it's
let's see, I got 6 there and 14.
Yeah, I got-
146,
I got-
is that a perfect square root?
No.
No, I got 146 squared.
That's what I've got too.
Alright, cool.
square root of.
Square root.
Yeah, you
Yeah,
know
yeah,
what
yeah,
I mean.
yeah.
Can you not take anything out of it?
I can take a 2 out of it, for sure.
Nah, you can't. You can't make it any less.
Well, you can do
Not.
7 and 3. 73 is prime, isn't it?
Yeah.
Yeah.
Right.
Okay.
So we could just leave it. Yeah.
No, you can delete it. Yeah.
You sure?
Yeah, this is my calculation.
Why don't we just look in the back of the
I don't do the factory thing. I put it in my calculation.
What happens when that one you can't use on a standardized test when you're in ACTs and SATs?
We're
You have to know how to do this.
I
Not
know
that
how.
kind. Our
It's
kind,
Good.
yes. but
All
not
right, as
that
long as
kind.
you know how.
And how you just like do it down. If there's doubles, you take it out.
All right, all right, all right. All right, now what's next? It was 9.
I know how. It's just hard.
Number 9. Are you ready?
Number 9.
Number 9. This is a new kind. We're going to combine the Pythagorean theorem and area of a triangle. We're doing 2 things here. You've learned about area of a triangle before. Now we're going to add the Pythagorean theorem to it. How do you find the area of a triangle? Let's read it first. Find the area of a triangle. Round intermediate values to the 10th.
Huh?
I'll show you what that means. Use the rounded values to calculate the next value. And round your final answer to the nearest 10th.
Say what?
Okay, let's do this together. That's why we're doing it. What's the formula for finding the area of a triangle?
A equals 1/2 base times height.
So we're doing that like plus a squared plus b squared. What?
Yes. Okay, so on this little triangle here, which one's the height and which one's the base? Which was B and H?
5 is
5 is
the
base.
height. Wait, no.
5 is the height. What's the base?
Oh, we don't have a base.
You don't know it.
X, right?
All right, so how are we going to find it?
Oh, we have to find the.
We have to find it.
Find it.
Yes,
We have
by
to-
doing what?
Pythagorean theorem.
Pythagorean theorem. So I'm going to come down here and go
Say that.
5 squared plus x squared equals 11 squared. I don't know. What's 121 minus 25? Can someone help with that?
Okay.
96.
Okay.
Oh, drat. It's not a perfect square root.
4 square root 6.
Okay.
Ah.
Do yourself a favor here. Stop right here and don't go any further. I need you to help. I need you to understand. Don't write the 4 squared 6 or whatever you just got.
Oh.
Don't do a factor tree. They tell you in the instructions up here
Just leave it.
to round.
Intermediate value to the nearest 10th.
So take the, figure out what the square root of 96 is
9.8.
with 1 decimal.
9.8.
I heard 9.8, so you just calculate it with 1 decimal. So x is 9.8. You just leave 1 decimal, all right?
Yeah, okay.
Okay, so now we're going to plug it into this area formula over here. 1/2, the base was 9.8, and the height was 5. This is where I'm going to help you on your calculator. Do all of that in one step. Don't hit
Yeah.
enter 1,000 times because it actually will start making mistakes.
Really?
Well, one time you told us to do that, but I always just like.
Same.
I just do 9.8 times 5, and then with mine, I can just press the divide.
Divide
and
two,
it'll
that's what
put
I
do.
the
I
just do it like
answer
that.
down.
Yeah, that's
Yeah.
what I
Just
do.
put 2.
That's exactly what you do.
I just do it like that.
Yep, 24.5. All right, we got 24.5 as our answer. There's no units on that, so we're done. That's our area.
I skipped 10 because I skipped 10 because we were doing that together.
Let's do number 10. Oh, wait, was it 10? Did you want to do?
Yeah, we were supposed to do 10 as well. That was on the list.
Oh, is this one a Pythagorean triple?
3, 4, yeah.
Yeah.
Number 10.
4, 5, so it would be.
No, it's not, you guys.
Well, wait, but it's 6.
12 is not
No, it's not.
part of
Oh,
5.
but it's yeah. Okay.
Are we finding the base or the height on this one?
We're finding the.
Wait.
We're finding the height, wouldn't it? Well,
Yes.
technically. Yeah.
It wouldn't really matter.
Yeah.
Because if you turn it over, so we're going to do a squared plus b squared equals c squared. It's 12 squared plus x squared.
No,
equals
6 squared plus x squared equals 12
matter,
squared.
does it?
x squared plus 6
Does it
squared.
matter?
As long, I can't put a plus, I have to put an equals. It does not matter if I put 6 and x in the different place, but 12 has to be the equals at the other side. All right. 12 squared is 144. 6 is 36. 6 squared is 36.
Do we just leave it as a square root and do it that way? Can we?
You might be a decimal off if you don't follow the instructions that they're given up there. But 144 minus 36 is how much?
10.4.
Ten-
Wait, no. I'm sorry. I 108.
Square root of that. So what's square root of 108?
Square root of 108 is
10.3.
10.3.
Yeah, I know it's
10.4.
Okay.
10.4.
So we're going to plug that in, 1/2. The base is 6, and the height is the 10.4. When we put all that in our calculator, you got 32.4 or 0.5?
30. Wait, what?
1.2. Is that right?
Yeah.
Can you guys look up here and verify with me? There's no units? All right, I'm going to double check. Amy, did you get it round right when you put your square root of 108 in there?
I got 31.2.
And you put the square root of 108 right in there instead? Okay, cool. All right, let's just verify. Verify. I got 31.2. All right. Let's go back and see what we did, just to recap. I've got a cute little joke up here, so pay attention. It'll be funny. Promise.
Are
All right.
you sure?
We talked about our Pythagorean triples. We talked about the Pythagorean theorem. And here we go. We got a golf guy doing square roots. And he's doing the math club. And he's, instead of saying 4, he's doing the square root of 16. Square root of 16! Doesn't sound quite as good, but hope this helped. Goodbye.